Hello viewers, welcome to my channel. I'm Hasham. Now I'm going to start the new topic in statistics for management subject. The new topic is regression analysis. The previous videos I have completed the topic of correlation analysis. There is relationship between these two topics, correlation and regression. Both have some similarities as well as differences. The similarities are correlation and regression both are applied for related variables. When two or more variables have some relationship between them, then we can apply correlation and also we can apply regression. So in this video, I'm going to explain you about the meaning of the term regression. What are the different types of regression? What is the significance or importance of regression? What are the different regression equations? Properties of regression coefficients and the differences between correlation and regression. All these things I'm going to explain you, so watch the video till the end, don't skip in between, because the problems are based on the theory. If you are having good knowledge of theory, you don't find any difficulty in understanding the problem. From that perspective, watch this theory video completely. Take the screenshot of the points which I have written on the board, then I'll explain each and every point in detail. Come on, before starting the topic of regression, first we'll recap the points what we have studied in correlation. Correlation is a statistical technique which is applied to find out the relationship between two variables. What is the nature of relationship and what is the degree of relationship? Whether positive relationship or negative relationship, whether there is a high degree relationship or low degree relationship. To find out that relationship, we have applied correlation. Now regression is also one of the statistical technique which is applied to find out the average relationship. That means to find out the functional relationship between the two variables. We are going to form an equation. That equation will explain the average relationship between the variables. So in simple words, regression analysis is a technique, statistical technique which is applied to find out the functional relationship, to find out the mathematical relationship in the form of an equation between the two variables. So here formally we can study like this. Regression analysis is concerned with derivation of an appropriate functional relationship between variables. We are making a functional relationship. Function we are making. Relationship between two variables. We are not just stating whether there is positive or negative relationship. We are making an equation. Mathematical equation showing the average relationship between the two variables. Now it's a mathematical measure expressing the average relationship between two or more variables. Just now I told you it's a mathematical equation which shows the average relationship between two or more variables. Regression analysis is a statistical device with the help of which we can estimate or predict the unknown value of one variable from known value of another variable. Very important point here. This regression analysis is a statistical device through which we are forming an equation, mathematical equation. By using that mathematical equation, we can be able to predict one value given the value of the other variable. Two variables are there. We are having y variable. By using that y variable, we can be able to predict x variable. Or x variable is given. By using this x variable, we can predict what would be the y variable. The prediction is possible with the help of regression. Prediction is not possible with correlation. It will just explain the nature, positive, negative. But here, it will give you the estimated value of one variable given the value of the other variable. That is the device. And the prediction or estimation is one of the major problems in almost all sphere of human activity. See here, prediction, estimation is the main human activity in every field. Whether it is a business field or government field or social field, we have to make a lot of predictions about the future. Simply, management. In management, the first function of management is planning, deciding in advance what is to be done in future. And planning requires forecasting, prediction, estimation. So without forecasting, without estimation, without predicting, planning is not possible. And without planning, no management can function. So every sphere of activity, planning is required. And for planning, prediction is required. So regression analysis is a tool of prediction, of estimation. Now, in the field of business, this tool of statistical analysis is widely used. Actually, prediction is required in every field. Whether it is a business field or medical field or legal field or accounting field, every field there is prediction. But from business point of view, prediction is more particularly required for cases the estimation or prediction for future production. A business has to make estimation about the future production. How much production we have to make in the future. Similarly, consumption. What is the estimated consumption? Because production depends on consumption. The producer will make only that much quantity which is demanded, which is consumed. So we have to make the estimation of production, we have to make the estimation of consumption, prices. In inflationary conditions, the prices will go up. When the prices goes up, the demand will come down, the sales may come down. So we have to make the estimation how much prices may increase, how much sales may decrease. Similarly, investment, sales, profit, income, etc. are of great importance to a businessman. A businessman is interested in estimating the production, estimating the consumption, estimating the prices, estimating the income, estimating the profits. All these estimations will be done by the businessman. So for making those estimations, we need some tool and technique. And this regression analysis is the best technique for prediction, for estimation of one variable given the value of the other variable. That's it. So this explains the meaning of the term regression analysis. Now, with the help of regression analysis, we can estimate or predict the effect of one variable over the other. We can be able to estimate. Example, simple example. If we spend suppose 1 lakh rupees on advertisement, how much would be the sale? How much estimated sales we can make by spending an amount of 1 lakh on advertisement? So two variables are there, advertisement, sales, both are related, both will change. When advertisement changes, sales will change. Suppose we spent 1 lakh rupees on advertisement, how much would be the sales? We are predicting sales given advertisement. This is the example. Now, simple and multiple regression. Regression can be broadly divided into simple and multiple. Simple regression means only two variables are there. When only two variables are considered for making the mathematical equation, that is called simple regression. Example, we assume that sales depends only on advertisement. That means sales will change only on account of advertisement. So we are making a relationship between advertisement and sales. It's called simple regression because only two factors are considered. Suppose if there are more than two variables are affected, then it is called multiple regression. Example, the sales does not depend only on advertisement. The sales will depend on the price of the goods. The sales will depend on the competition in the market. The sales will depend on the income of the people. The sales will depend on the taste and habits and fashions of the people. So all these are the factors which affects the sales. So if we make an equation considering all the factors, it is called multiple regression. It is called the regression analysis which studies more than two variables at a time is called multiple regression. That's it. This will be asked in examination in a theory question regarding what is simple and multiple regression. This discussion is more than enough. Next, regression equations. When we have simple regression, only two variables, x and y, so we have two regression equations. In a regression analysis, if we have only two variables, then we will have simple regression. In simple regression, two equations are there. One equation is regression equation of x on y, and the other equation is regression equation of y on x. So in the coming problems, almost every problem we are going to make two regression equations, x on y and y on x. The regression equation of x on y gives the most probable value of x for a given value of y. Now remember this point, very important point. The regression equation of x on y will be used to predict the value of x for a given value of y. That means when y is given, x we have to estimate. In that case, we use the regression equation x on y. Similarly, regression equation of y on x. The y on x equation is used to predict y for a given value of x. If x value is given, we need to find out y. So we use y on x. This is the application of two regression equation x on y and y on x. Next thing is importance or significance of regression analysis. Is it important or not? It's very, very important. Particularly in a business organization, a business has to make a number of plans, a number of estimations are required, predictions are required. In that case, it will become a handy tool in the hands of the management. So the significance is paramount. First one, predict or estimate the value of a variable based on some other variable. We can be able to predict one variable for a given value of the other variable. That is the first importance, advantage. Second, measure and estimate the relationship between variables. We can be able to find out whether relationship exists or not. Then third one, provide a basis for policy formulation. Simply plans. This regression analysis is a handy tool in the management, in the hands of the management to make the policies, to make the future plans. So this shows the importance of regression analysis. Next come differences between correlation and regression. Very frequently in examination, theory question is asked, what are the differences? I told you many similarities are there. The similarities are the correlation and regression will be applied for related variables. If two variables are related, if there is relationship, then only we can apply correlation, then only we can apply regression. If there is no relationship, no correlation, no regression. That is the similarity. But what are the differences? The first difference. Correlation indicates the nature and degree of relationship between variables. First of all, the correlation is a statistical technique which explains the nature of relationship and degree of relation. Nature means positive relationship or negative. Degree means is it a high degree relationship or low degree. That's what we can get from correlation. But regression, we can be able to estimate one value given the value of the other variable, related variable. Two related variables are there in which one value is given. We can predict the other value by using regression equation. That's it. Now, correlation is independent of change in origin or scale. Regression is independent of change in origin, but not of scale. Now, another difference. While calculating correlation, the correlation coefficient is independent of change in origin and change in scale. Already I explained you in the last video in correlation. What do you mean by change in origin and change in scale? If we add up a constant value to all the variables, or if we deduct a constant value from all the variables, the R value will not get affected. The correlation coefficient will not get affected. If we add or subtract, that is called change of origin. Change of scale. Suppose if we multiply all the variables by a constant, or if we divide all the variables by a constant, the value of R will not get affected. This is called change in scale. So in correlation, the coefficient of correlation is independent of change in origin, change in scale. You can make any change. But in regression, it is independent of origin, not of scale. But not of scale. That's it. Next one, correlation does not indicate a cause and effect relationship. Regression studies a causal relationship between the variables. See here, there is no causal relationship in case of correlation. The correlation technique will explain is the relationship or not. It will not show what is the cause and what is the effect. But here in regression analysis, it will show the causal relationship. What is the cause? What is the effect? Example, the cause is we are increasing advertisement. The effect is the sales are increasing. So cause, increase in advertisement. Effect, increase in sales. Secondly, if there is increase in the price of petrol, there is a decrease in the demand of vehicle. The cause is increase in price of petrol. The effect is decrease in the demand for vehicles. The causal effect is there in regression. No causal effect in correlation. Next one is correlation is symmetrical in formation. Symmetrical means whether we calculate correlation for x or y on x, we'll get the same correlation. Example, we treat first series as x, second series as y. Or we treat y series as first series, x series as second series. The correlation coefficient is symmetrical, it will be same. Whether you take x as first or y as first, the correlation coefficient will remain same. But in case of regression, the regression coefficient of x on y will be different from y on x. That is a change. Last one, this one, or. So these are 4 differences I explained you about correlation and regression. Next comes properties of regression coefficients. Very frequently in examination, a question will be asked regarding what are the properties of regression coefficients. What is regression coefficient? I'll explain in the next coming video when we do the problems. But right now remember, regression coefficient property. The first property is the correlation coefficient is the geometric mean of the 2 regression coefficients. The regression coefficients are bxy and byx. The bxy is a symbol for regression coefficient of x on y, and byx is the regression coefficient of y on x. When we find the geometric mean of these 2 regression coefficients, we will get correlation coefficient. The symbol for correlation coefficient is R. We can get R simply by multiplying bxy into byx under root. This is the first property. Bxy into byx under root, we'll get R value. R value is the correlation coefficient. It is called the geometric mean of the 2 regression coefficients. That's it. Second, both the regression coefficient will have the same sign, that is either both are positive or both are negative. Remember, very important point. In problems, while doing the problem, you will come across a situation where you are getting bxy positive, byx negative. That means your calculations are wrong. Because one of the properties says both the regression coefficient must show the same sign. If bxy is positive, byx should also be positive. If bxy is negative, byx should also be negative. Both are positive or both are negative. You should never get one positive, one negative. Next one, if one of the regression coefficient is greater than 1, the other has to be less than 1. Very important property. If one regression coefficient is unity or above, 1 or more, then the other coefficient must be less than 1. Example, if you calculate bxy, this is the regression coefficient of x on y. You got suppose 3.5. 3.5. Similarly, when you calculate byx, you got 1.2. If you get this situation, your calculations are absolutely wrong, because property says If one regression coefficient is more than 1, the other should be less than 1. For example, if this is 3.5, this should be 0.2. 0.2 means less than 1. This is more than 1, this is less than 1. This may happen. But both are more than 1, it should never happen. Right? Both may be less than 1 also. It is possible. For example, you are getting bxy as 0.5 and byx as 0.2. It is right. It is possible. Both may be below less than 1, below 1, or one is above 1, the other is below 1. It is possible. But both are more than 1. Not possible. That is the property. Last one, the arithmetic mean of the two regression coefficients should be greater than the correlation coefficient. The arithmetic mean means we add up bxy plus byx divided by 2. This bxy, byx divided by 2. This is the arithmetic mean of the two regression coefficient. This should be greater than the correlation. What is correlation? R. R is the symbol for correlation. So bxy plus byx divided by 2. This is the arithmetic mean. This should be greater than the correlation coefficient. That's all. So these four are the properties of regression coefficients. So I have explained you about the meaning of the correlation coefficient. Then I have explained about the simple and multiple types of correlation. Then regression equations are there, importance or significance, differences between correlation and regression, and lastly properties of regression coefficients. So now I am going to explain you about the regression equations. Two regression equations are there. Regression equation of x on y and regression equation of y on x. The regression equation of x on y is used to predict x for a given value of y. Similarly, the regression equation of y on x is used to predict y for a given value of x. So how to make the regression equations? The formulas I have written on the board. So take a screenshot of all the formulas, then I'll explain each and every formula. So now, regression equations. Two regression equations are there. First of all, I am explaining x on y. Regression equation of x on y. The equation is x minus x bar is equal to bxy into y minus y bar. Similarly, regression equation of y on x is y minus y bar is equal to byx into x minus x bar. For x on y, on LHS we should take x. For y on x, on LHS we'll take y. That point you have to remember. X minus x bar is equal to bxy into y minus y bar. This is the regression equation x on y. Y on x, y minus y bar is equal to byx into x minus x bar. Where x bar and y bar are the actual mean of x and y series. So first of all, x series and y series data is given. To calculate the actual mean of x and y. So x bar is the actual mean of x series and y bar is the actual mean of the y series. And bxy. What does this bxy and byx denote? Bxy is called regression coefficient of x on y. Regression coefficient of x on y. And byx is called regression coefficient of y on x. All these terms you should be clear in your mind. So while doing the problem, there should be no confusion at all. Bxy regression coefficient of x on y. Byx regression coefficient of y on x. Now how to calculate this regression coefficient? Ultimately, the main problem is how to find out bxy and byx. So different formulas are there depending on the information given in the problem. So first of all, regression coefficient. First I am taking regression coefficient of x on y. x1y regression coefficient is bxy. So how to find out bxy? Three formulas I have given here. Depending on the information given in the problem, we apply that formula. What are the three cases? First case, if standard deviation and correlation coefficient are given. If in the problem, the standard deviation of x series and the standard deviation of y series are given and correlation coefficient R value is also given. In that case, the formula is bxy is equal to R into sigma x by sigma y. This is the standard deviation of x series and this is standard deviation of y series. So numerator we have taken x because it is bxy. First of all, concentrate on the first alphabet. The first alphabet is x. The first alphabet is x. So bxy is equal to R into sigma x by sigma y. By using this formula, we can get bxy. But this formula will be used only when standard deviation and correlation coefficient are given. Every problem it will not be given. If it is given, then this formula. Otherwise, other formulas are there. What is the next formula? If the deviations are taken from actual mean. So in the problem, first you have to calculate the mean. If the actual mean happens to be whole number, if the actual mean is in whole number, then take the deviations from actual mean. Take the deviations from actual mean. What we have done in correlation chapter, previous videos. So there are two formula, actual mean formula, assumed mean formula. Here also, if the actual mean is in a whole number, take the deviation from actual mean and apply the formula bxy is equal to summation xy divided by summation y square. Remember the formula. Summation xy divided by summation y square. This formula will be applied when deviations are taken from actual mean. Now, if deviations are taken from assumed mean, suppose if the actual mean is in fraction, it is you are getting in point. So if actual mean is fraction, take the deviations from assumed mean. So if you have taken the deviations from assumed mean, the formula for bxy is summation dx dy minus summation dx into summation dy by n whole divided by summation dy square minus summation dy whole square by n. No under root. Under root is not there. Summation dy square minus summation dy whole square by n. This formula will give you bxy if the deviations are taken from assumed mean. And this formula when the deviations are taken from actual mean. One point to be remembered here, the denominator. Here the first alphabet is bxy. When the first alphabet is x, here in denominator you take y square, opposite. When your first alphabet is x, denominator is y square. Here also same thing. First alphabet is x, the denominator is dy square. No dx square, only dy square. So these are the three formulas of bxy, right? Similarly, we have to calculate the regression coefficient of y on x. So here, regression coefficient of y on x. If standard deviation and correlation coefficient are given, just like the previous here, if in the problem standard deviations and correlation are given, then byx is equal to r into sigma y by sigma x. Now you compare these two formulas. bxy is equal to r into sigma x by sigma y. byx is equal to r into sigma y by sigma x. So numerator. Here first alphabet is y, so numerator is also y. Here first alphabet is x, so numerator is also x. That's it. Comparative form like this you have to remember. Then if deviations are taken from actual mean, the formula for byx is summation xy divided by summation x square. Now compare it with bxy. In bxy, summation xy by summation y square. Here summation xy by summation x square. Similarity is the numerators are same. Here the numerator is bxy, here also numerator is bxy. Here denominator is summation y square. When the alphabet is x, denominator is y. When the alphabet is y, denominator is x, opposite, ulta. So summation xy divided by summation x square. This formula will be applied when deviations are taken from actual mean. If deviations are taken from assumed mean, then the formula will be byx is equal to summation dx dy minus summation dx into summation dy by n divided by summation dx square minus summation dx whole square by n. That's it. Now compare it with bxy. The numerator both are same. For calculating bxy or for calculating byx, the numerator is same. Summation dx dy minus summation dx into summation dy by n. Here also same. Summation dx dy minus summation dx into summation dy by n. Numerator same. Denominator will change. Here denominator is dy square. Because first alphabet is x, so denominator is y. Summation dy square. Here first alphabet is y, so denominator is x, ulta, opposite, dx square minus summation dx whole square by n. That's it. So all these are the formulas we have to apply in the coming problems for making regression equations. Now properties. Already just now I have explained you the properties of regression coefficient. That is very, very important. You have to remember. Again I am repeating here. R is equal to summation bxy into summation byx under root. If you multiply the two regression coefficients and put it under root, you will get R value. What is R? Correlation coefficient. So we can get correlation coefficient simply by multiplying regression coefficient and putting under root. Second, both regression coefficient cannot exceed 1. If bxy is more than 1, then byx should be less than 1. Both should not exceed 1. If one regression coefficient is more than 1, the other must be less than 1. Both regression coefficient must have the same sign. If bxy is positive, byx should also be positive. If bxy is negative, byx should also be negative. Both positive or both negative. You should never get one positive, one negative. Then when both regression coefficients are negative, then correlation coefficient should also be taken as negative. If you find bxy negative and byx also negative, in that case correlation coefficient, here what you calculate, this correlation coefficient should also be taken as negative. That's all. So this is the end of the theoretical part of the topic regression analysis. In the next video, inshallah, I will start the problems on regression analysis. So if you are satisfied, give a like to the video. Share my channel among your group, among your friend circle, so that more students can watch the video and enhance the knowledge. Give your comments on these videos. Where are you from? From which university you are pursuing the course? What you are doing? BBA, MBA, BCom, BBS, etc. or CA, etc. So from where you are pursuing your education, give me through your comment. And lastly, don't forget to subscribe my channel. Inshallah, next video I'll start the problems on regression analysis.